Hello, discrete math fans. Let's try this problem. Let's suppose that a real number c is the root of a cubic polynomial with rational coefficients. What we want to do is prove that c is the root of a cubic polynomial with integer coefficients. Now, first we ought to explain what we mean when we say that c is the root of a cubic polynomial. So a cubic polynomial is of this form: a3x cubed plus a2x squared plus a1x plus a naught. And the coefficients are real numbers. Now in this case, we're specifically talking about polynomials with rational coefficients, so the polynomial looks like r3x cubed plus r2x squared plus r1x plus r0, where all these coefficients are rational numbers. So finally, what do we mean when we say that c is a root of a polynomial like this? That means when we plug in x equals c, we get 0. So r3c cubed plus r2c squared plus r1c plus r naught is equal to 0. So now let's suppose that c is in fact a root of this polynomial. Now we know that r3, r2, r1, and r0 are rational numbers, so that means we can find integers and make fractions to replace each one of these rational numbers. So r sub k is equal to a sub k over b sub k. So k can be anything from 0 to 3, and it's important to note that each b sub k is non-zero. So now our polynomial with the c plugged in looks like this: a3 over b3 c cubed plus a2 over b2 c squared plus a1 over b1 c plus a naught over b naught. Now all we're going to do is just say, let's just get rid of the fractions. We say this all the time in algebra classes. We want to try to get rid of fractions to make things simpler. So if we have an equation like this, we can clear fractions by just multiplying everything by b3, b2, b1, b0. That whole thing multiplied together. What we're doing is we're multiplying by a common denominator. Now, it doesn't have to be this. Sometimes you might come up with a least common denominator, but we're not really going to worry about that. We're not trying to find the most efficient route here. We're just trying to find a route. And plus, we don't even really know the values of the b's, so there's no way of saying what the least common denominator would be. So if we multiply everything by that common denominator, that clears all the fractions, and we get an expression that looks like this. And the thing to note now is that each one of these coefficients in front of c is an integer. Each coefficient is a product of integers, and that means each coefficient is an integer, and now we've proven what we wanted. We now have a polynomial expression where c is a root and all the coefficients are integers. That's what we were trying to prove. Okay, that's all for now.